Chapter 10 is going to start us out with human population and its impact. Kind of keep in mind the idea that as population goes up, human population that is, our environmental impact tends to skyrocket. Reason is, as more population goes up, more food we need, which means the more land we need to clear, aka deforestation, which means we need to add more fertilizers and pesticides and just a whole bunch of the different things. Groundwater get contaminated from the pesticides. Eutrophication occurs from the excess of fertilizers, so just a lot of ramifications with that. I'm going to start a little picture here. This was in 1930, which was when world wars were going on, of course. Take a look at the world populations. China and India, of course, high. Europe, pretty high. United States, starting to get higher. And if we go from there, we got 2 billion people in. A couple little pictures here. I'm going to kind of go through these relatively quick. You can take a look at the population in 1930 and what happened at 1930s. In 1960, you can see what happened as modern medicine. We're getting more people. We're up to 3 billion. 1975, continuing modern medicine, we're up to 4 billion. 1987, we're up to 5 billion people. 1999, you can see our world population is at about 6 billion people. It was actually October of 1999 when we hit 6 billion people. If you take a look at this picture, 2030, it is projected that in our information age, we're going to reach about 8 billion people, if not higher. That has huge significance in our environment. So our world population is deemed to be growing at an exponential rate, or a J-shaped curve, thus the J-shaped curve like this. The difference between these pictures is the developing countries are in the lighter color. Developing countries by far are getting more populated, and we will talk about reasons in a little bit. Developed or industrialized nations like the United States are kind of leveling off, and again, we'll get into that soon. Hey, are there too many people out there? Current population by country, we will look that up in class. It's estimated that 2.4 billion more people will be added by 2050, and that may be an underestimation at this point. Keep in mind as I go through this, a lot of these numbers change constantly. The question is, are there too many people already? Will technological advances overcome environmental resistance that populations face? We, of course, humans tend to write our own path, kind of change the course of evolution quite a bit, so maybe we'll be able to sustain those numbers. Should populations be controlled? Huge ethical problem China dealt with their one-child law. So are there too many of us? Will growing populations cause increased environmental stresses? We know that as we get closer together, we get infectious diseases spread much quicker. We lose biodiversity because we're cutting down those forests. We get water shortages. That's happening around the world. We get traffic congestion. Not fun. Pollution of the seas. We get climate change. All of our population going up. The study of size, composition, distribution of human populations is called demography or demographics. Excellent field to go into. And the causes and consequences of change. You can see that cool picture down there at night. That picture actually, as a side note, was not taken all at one time because, of course, we'd be around as a globe. Plus, we're not all in darkness at one time. Actually, two pictures put together. How do we determine current growth rates? Again, we'll take a look at those numbers in a activity that we do. Right now, we have more births than deaths in the world. Plus, we have less of a death rate going on. That is the essence of why we are growing so fast, is because people are living longer. Modern medicine, better inoculations, things of that nature. Population change is calculated by birth rate minus death rate divided by 1,000 times 100. We'll practice that in class, so don't get about that right now. So the human population can grow, we could decline, we could maintain fairly stable amounts. Look at that newborn baby. Anyway, a couple things that come into play with population change: birth rate, also known as fertility rate, death rate or mortality rate, and migration. If people are coming into a nation, obviously that, and via immigration, that is going to cause a number to go up. Emigration, by the way, is going out of a country. We'll talk about factors on that. Population change is births plus immigration minus deaths plus immigration. Think about that for a minute. If we have a high amount of births and you have a high amount of people coming into your country, what happens is your population goes up. If you have a high amount of deaths and a lot of people leaving, countries like Somalia right now, a lot of people are fleeing that nation because it's war-torn, poor people. What happens is your population is going to go down. Crude, whenever you see the word crude, think 1,000. Crude birth rate is the number of births divided by 1,000. Crude death rate is deaths divided by Between 1963 and 2004, growth rate dropped in half, yet the population doubled. The reason is we've got such a huge base, billions of people. No matter what percentage of growth we have, even small, we're going to add a lot of people because we have that really small base. About 219,000 more people are born each day. 97% of those are in developing countries, a lot of African nations, and of course areas like China and couple little charts here, right here, average crude birth rate, average crude death rate. These could be a little bit different now. In the world, you can see right here, we have 21 births for every 9 deaths. Boom, that's the growth rate right there. In developed countries, 11 versus 10. We're still growing in developed countries, but not nearly as fast as developing. Take a look at developing countries, China and India, Africa. For every 24 born, 8 die. A lot of kids are being born. Developing without China, 27 and 9, which says a lot. A couple little comparisons here too. We've got Africa, 38 being born, 14 dying. Huge growth rate in a lot of those countries on the African continent. Latin America, 22 to 6. Asia, 20 to 7. Oceania, Pacific Rim, like Japan, 18 to 7. United States, 14 to 8. So we're growing. 14 people born for every 8 that die. The reason is we have a lot of people dying, unfortunately, but they're living longer. North America in general, 14 to 8. And Europe is 10 to, I believe that's 15. They're actually going in a negative direction. We'll try. Fastest growing nations as of right now, India, China, Pakistan, Nigeria, Bangladesh, and Indonesia. That may change. We will look this up in class. Highest current population, again, what's expected is India will surpass China. 1.3 billion and 1.2 billion. So there's roughly 7 billion people in the world right now. That's 2.5 billion of those people living in two relatively small nations. Population growth, what we're going to do is we're going to calculate this thing called doubling time. You may have done this in math class. You use the rule of 72 in there. We use the rule of 70. I have no idea why. We just use the rule of 70. In order to figure out how long it's going to take for a population to double, we take 70 divided by the growth rate expressed as a percent. So if the growth rate of a nation is 1.2, you take 70 divided by 1.25. You don't, actually this should say 1.25, sorry. You do not change that to 0.0125 or anything like that. What that says, 70 divided by 1.25, it'll take 56 years for a population to double, and I believe that's kind of what we're at with the United States. So we're at about 300 million right now. If we continue on that growth rate pattern, we're going to double our population in 56 years. So by time you guys are in your 70s, we could be looking at 600 million people in the United States. So that'll be a yes. Growth rate, of course, here's another problem. 70 divided by doubling time and 70 divided by 15, the doubling time amount of years, is growth rate of 5%. So just another way of doing the math. We'll do some math, relatively simple. So women are having fewer babies, but not few enough to stabilize the world's population. Two ways of looking at this fertility rate idea. We'll look these numbers up. Again, because they're constantly changing. Replacement level fertility rate versus total fertility rate. This is a little confusing. Replacement level fertility is the average number of kids a couple has to replace themselves. Scary thing is, okay, you have a mom and a dad. Replacement level should be 2 because 2 kids replace 2 parents. But in some places, more than others in the world, sometimes kids die before reproductive age. So in developed countries, the average is actually 2.1. In developing countries, 2.5. Total fertility rate, a little bit easier to understand. Average number of kids born to a woman during her lifetime. Globally, that is 2.8. United States, it is, or in developed nations, it's a little bit lower. We'll take a look. In the United States, we have this magical time between 1946 and 64 called the baby boom era. Know those years. What happened was the boys came back from World War II, and we had a lot of kids skyrocketing. That is causing a lot of socioeconomic problems right now, especially with Social Security. And those people are getting older, which is great to be in the healthcare industry right now in some regards, because those people are getting older and they need care of. The U.S. population is growing rapidly. Drop in the TFR, total fertility rate, in the United States, it's definitely slowed down. We're having less kids. If you think a couple generations back, a lot of people in the United States did farming and they had large families. Population still growing and not leveling off. It's been a 4-fold increase since 1900. Changes in lifestyles. One of the big changes in lifestyles is women are now going to college and going to higher degrees, so females are not having kids until in their 30s, which then you tend to have less kids at that point. How do factors that affect birth rates and fertility rates? There's something called infant mortality rate. A very terrible thing, but infant mortality rate is a reality. That is when a baby dies before their first birthday. What that means is, what's really weird about it is that couples that tend to have a baby die before their first birthday tend to have more kids. Not sure of the psychology behind that, but it's kind of a fact. Average age of a woman at birth of first child is, of course, as I mentioned, going up, which means they tend to have less kids. It was very common a couple generations ago where women would start having kids at 17, 18. Availability of legal abortions is a factor around the world. Availability of reliable birth control is a huge issue around the world, and religious beliefs obviously really come into play. In the United States, unfortunately, we have very high infant mortality rate. You would not think that because we are a developed country, but the difference is we have great distinction between the healthcare system, within the healthcare system, of those people getting healthcare and those not. We have very inadequate healthcare for poor women during pregnancy and their infants. That may change with recent changes in our government. Drug addiction among pregnant women is also really huge. So obviously what happens is we get terrible, terrible, terrible situations where babies are born addicted to different drugs, and obviously what that causes is premature death too. And we have a high birth rate among teenagers. Traditionally, unfortunately, Milwaukee generally leads the United States in teen rates. Several factors affect birth rates and fertility rates. Children are used as part of the labor force in the United States. A couple years ago, farmers had a lot of kids. They wanted a lot of help on the farms. Kind of counterintuitive because you need to feed more kids, but that is reality. A lot of nations where they do sustenance farming, which means they grow their own food and feed their own family, they have a lot of kids. The cost of raising the child and educating them is really a significant factor, particularly in developed countries. It is really expensive to have kids. By the time 0 to 18, you're going to cost your parents probably $300,000-$400,000. Then college is going to come into play, so that's a huge factor. Availability of private-public pension is a huge factor. A couple generations ago, or if not last one, it's very common for when grandma and grandpa were getting older, they'd come live with the parents, or grandkids rather, with your parents, and that's not really the case anymore. Now we've got beautiful nursing homes and things like that, which is a little bit more common. Urbanization, as we're moving into cities, we'll talk about that factor down the road. Educational and employment opportunities for women too. Women are getting in the workforce, making a huge difference. Last little slide, hey, look at that happy little man. Measuring a country's overall health, there's something called life expectancy. Infant mortality rate, we said, is the number of babies out of 100,000 births that die before age 1. So how do we look at a country's overall health? That life expectancy is a huge factor in infant mortality rate. Life expectancy is how old you are expected to live. Now I think it's like 80 for females and about 78 for males. Again, we can look at that. That's constantly changing. Why are people living longer and fewer infants dying? Well, we've got increased food supply, better food, we've got better nutrition, we're more aware of nutrition, medical advances, and of course improved sanitation. Keep in mind a lot of countries don't have that improved sanitation. If you don't have proper sanitation, you tend to spread disease much quicker. All right, that's it for part 1 of Chapter 10. We'll hit part 2 in a bit.